Hi, my name is Christina Merritt. This is my demo lesson for Jade Class Education. I chose to do problems 3 and 5 off the demo suggested list. For this first question, we're talking about a right cylinder being taken out of a cube. So if I were teaching this, I would first remind students what the surface area of the whole cube was. So in order to find the surface area of the cube, we know that each edge is 10 centimeters. And so I've written that down there. And we're going to look at the area of the front of the figure plus the back of the figure. Then the area of the top of the figure and the bottom of the figure. And finally the area of the side plus the other side of the figure. So we know that a cube is going to have all the sides going to be the same area. But to kind of show the students where that's coming from, I would start by doing 2 times the 10 times 10 plus 2 times 10 times 10 plus 2 times 10 times 10 for all the different sides. Then I would talk to them about the fact that, okay, all the sides are the same, so we could just really do 6 times 10 times 10. So the surface area of the whole cube is going to be 600 centimeters squared. But when we go to take out a right cylinder out of the middle of that figure, we're going to have 2 places on the top, or 1 place on the top and 1 place on the bottom of the cube that's going to end up no longer being part of the surface area. That part's coming out. So in order to figure out that actual area, we have to find the area of the circle at the top of the cylinder and also the bottom of the cylinder. So the area of a circle is always pi r squared. We know the radius of the circle is 2 centimeters. So we can set that up. Area equals pi r squared. The directions or the question said to use 3 for pi just to simplify the math. So we'll do 3 times 2 squared, which gives us 3 times 4, which is 12 centimeters squared. So that's the top circle that was taken out when you took that cylinder out. We had another place on the bottom of the figure that was also being taken out. So really we multiply that by 2. So we're going to take that away from 600, and that's going to give us 600 minus the 24, which is going to be 576 centimeters squared. And that's going to be the surface area of the final figure once the right cylinder was taken out. Okay, so that would conclude that problem. Okay, now looking at problem number 5. Okay, problem number 5 dealt with multiplying binomial and relating it to the trinomial x squared plus mx plus 12. So a, b, and m all have to be integers. So when we're going to think about this, we want to think about what are the factors of 12. Because if I think about it in terms of factoring, that's how we go and find that first set of numbers. So 12 could be 1 times 12, 2 times 6, 3 times 4. 12 could also be negative 12 times negative 1, negative 2 times negative 6, and negative 3 times negative 4. Okay, so all of those are possible because if I have a positive times a positive, I get a positive, as well as a negative times a negative is a positive. So I could use an area model and sort of set this up and think about what is that left side really meaning for me to do. So I get x squared, I get a times b, and I get bx plus ax must equal mx. So essentially if I add a and b, I should get whatever m is. So because AB is equal to 12, I have all these possibilities of ways I can multiply to get 12. And by finding the sums of each of those, I'll get a list that tells me what the different possible values for m are. M could be 13, 8, or 7 based off my top set of numbers, or negative 13, negative 8, or negative 7. And that will conclude my list of m values.